Algebra 2. Today we're going to learn how to solve logarithmic equations. So we haven't graphed this year, and we're not going to, but I'm going to explain a few things with a graph. All right, so we have this coordinate plane here, and we have a graph, and it looks like this. And so this is your basic log parent function. So that is what a log looks like. So you'll notice as the graph comes down, it seems to be hugging this y-axis right here. And that's what it's going to do all the way down. It's never going to jump, and it's never going to cross over the y-axis. And that is because on the y-axis, there is this imaginary line called an asymptote. And it is at the line x equals 0. So an asymptote is an imaginary line that a graph approaches but will never, ever, ever cross. So due to this asymptote, so if you look, you don't have a graph anywhere over here. All a graph does is it gives you a visual representation of what your possible solutions are at any point in time. So the graph isn't over here at all, so that means that you can have no negative x values. All right, so we have an asymptote at x equals 0. You can have no negative x values. Therefore, you can't take the log of a negative number. So this would look something like log base 3 of negative 5. So that right there is, if you see a negative right there, this is no solution. So that's a little background information. So here is how we solve log equations. So I have log base 4 of x equals 5/2. I have the log on one side, and I have a number on the other side. Anytime you have an equation in the form log equals number, I want you to change form. So change form is what we just got done doing in the last section. If you look at your 9-2 notes, we learned how to go back and forth between log functions and exponential functions. So the log would read log base b of x equals y. When I say change form, I'm saying change it from log to exponential. So that would be to the y equals x. All right, so when I change form here, the 4 is your base, the 5/2 comes over and becomes an exponent, and the x goes over to the other side. So now you just simply need to enter this into your calculator. 4 to the 5/2 equals 32. On the next one, this is still in the form log equals number. So anytime you have log equals number, I want you to change form. So the 2x, you might want to circle that or put parentheses around it. That is functioning as one unit together. So the base is your 2, the 3 is your exponent, and that equals 2x. So generally what happens in Algebra 2 is I teach you one thing, and then your Algebra 1 skills should kick in and take over. 2 to the 3rd is 8. I know how to solve that equation. I'm just going to divide, and I get x equals 4 for a good answer on that one. So number 3, I have log of 4x plus 2 minus 5 equals negative 3. So I don't have the log isolated yet like I did with the others. So that is your first move. You have to isolate the log. You do that by adding 5 to both sides. So I have log of 4x plus 2 equals 2. All right, so now I have it in the form log equals number. So I like that. So now I'm ready to change form. Well, so I want to take my base and I want to drop it. So on the last video, I told you if you don't see a base, you should know what it is. And this means that you have a base of 10. So no base means it's 10. No base equals 10. So now I can change form. So I have 10 to the second equals 4x plus 2. And now I'm just going to do algebra and solve. 10 squared is 100. I need to solve for x, so I'm going to subtract 2 from both sides. I get 98 equals 4x. Divide everything by 4. And 98 fourths. If you had to reduce it, that would be 49 halves. If decimal answers were acceptable, you would have 24.5. So that is your good final answer on that one. On the last section, I said that if you have like 2 to the third equals 2 to the x, so we solved exponential equations by getting the same base. So if your bases are equal, we drop them and we set your exponents equal. So now exponentials and logs are similar because they're inverses of one another. If you have log base b of x equals log base b of y. So now our log base b and log base b, these are each the same. So here's what you're allowed to do. As long as these bases are the same, you could cancel them out and just set, I think it's called the argument. You can set x equal to y and continue on from there. So on number 4, I have log base 3 of this equals log base 3 of this. So I have it in the form log equals log, and they are each a base 3. So I'm going to drop the log and solve. So those two cancel each other out. And I have x plus 17 equals 3x plus 23. Now I gave myself an algebraic equation. I'm just going to do algebra and solve. Subtract x from both sides. Subtract 23 from both sides. Negative 6 equals 2x. Divide both sides by 2. And negative 3 equals x. All right, so you should be able to check these to a certain extent. Okay, so x equals negative 3. So if I have a negative 3 there, negative 3 plus 17 equals 14. Here, if you have a negative 3 there, 3 times negative 3 is negative 9, plus 23 gives you 14. So log base 3 of 14 equals log base 3 of 14. Looks good. Number 5. I have log base 2 of this equals log base 2 of this. So I have the same log, so I'm going to drop log, And I'm going to set x squared minus 4 equal to 3x. So what I have here is I have a quadratic. So you're supposed to know that a quadratic has to be set equal to 0. So I'm going to subtract 3x from both sides. I'm going to write out my equation in standard form. Now I can solve this. We solve by either factoring or running the quadratic formula. So I'm going to factor this. I need factors of -4 that add to -3. So -4 and 1 are the correct ones. So I write these factors out as x minus 4 and x plus 1 equals 0. Once you have them factored, you have to break them apart and set each of your factors equal to 0. And then I solved. So x equals 4 and x equals -1. Anytime you get two answers, you should absolutely check your work. So I'm going to check x equals 4 first. I'm going to plug it in two places because I have an x on both sides of the equal sign. So I have log base 2 of 4 squared minus 4 equals log base 2 of 3 times 4. Four squared is 16. 16 minus 4 is 12. And on the other side, 3 times 4 is 12. I have 12s in both positions, and 12 is a positive number, so x equals 4. That is a good answer. Now we're going to check x equals -1. So I have log base 2 of -1 squared minus 4 equals log base 2 of 3 times -1. I missed a parenthesis there. There we go. All right, so I'm going to do the math on the left. -1 squared is 1. 1 minus 4 is -3. I have log base 2 of -3. 3 times -1 is -3. So you might think that this one works as well because you end up with -3's on both sides. However, back in the beginning of the notes, I said you can't take the log of a negative number. So that is where the negative number is, that it's not okay to be there. So this, in fact, -1 is not a good answer. When you get an answer that when you plug it in becomes not an answer, this is called extraneous. I'm going to say that again better. When you do the algebra and you solve and you get an answer, you think it's going to be 1. However, when you take that number and you plug it into the original problem and it ends up failing you, that is no longer an answer, and that is called extraneous. One more. All right, there's lots of ways to do this problem. I'm going to show you the easiest one. This right side. On the quiz that you just took, you had to evaluate log base 2 of 1024. You used the change of base formula for that. The change of base formula said that if you have log base b of a, that you can take log a divided by log b. So anytime that you have a number as the base and a number right there, I recommend that you use the change of base formula. So I have 3x minus 5 equals log of 1024 divided by log of 2. So I plug this in my calculator. So I have log 1024, make sure you close the parentheses, divided by log 2 equals 10. Now I'm just going to do algebra and finish solving this. I'm going to add 5 to both sides. 3x equals 15. Divide. And get x equals 5 for a good final answer on that one. Well, thank you so much.